we'll roll into Chapter 10, Street Paving Design Requirements. This is the bulk of the review this year, so it's going to be split between myself, Ian, and Louise. I will be taking the first part and then hand it over to Ian for a bulk of Chapter 10. So here's, in front of you is a list of summary of significant changes I'll be discussing: update to the policy section, definitions, updates to align with the major thoroughfare plan, chapter rearrangement, changes to figures, alleys supplements incorporated, on-street parking supplement incorporated, figures removed, street transition length, and metro coordination. We want to point out we had a lot of discussion about the policy section. Each chapter in the IDM does include a policy section. Policy sets the overall arching rules of engagement, and then the IDM is actually the design criteria, but we do want to reference the policy. And one thing, in talking with Jeff Weatherford and TDO and working with our service line, we wanted to make sure that it was readily apparent that the design requirements set in this chapter are not intended to be the only values used for design. Where applicable, design requirements should be exceeded to enhance safety and comfort for all road users. I want to make sure that message to designers is out there, that this is not supposed to be an all-encompassing design section. That's all you need. These are minimums a lot of times, and we expect a designer to really look at their situation and provide, either by Green Book or other national standards, what's appropriate and what user engineering judgment appropriately. So we did actively pursue lining our Chapter 10 up with a major thoroughfare plan, particularly with nomenclature and use of terms. There's different terms that you will see throughout Class A or collector street, transit corridor streets, major thoroughfares. These terms, they just need to be used the same way throughout all of our documents. And so we spent a lot of time researching the major thoroughfare plan and making sure that took place. We also reorganized, as mentioned before, into 6 sections. A lot of items kind of spread out, hard to find. So in front of you, you'll see the 6 different sections for Chapter 10. And so, most of the information that you might need for pavement design requirements or bicycle facilities or street connections and transitions, you can go directly to those sections. So again, seems simple enough, but quite an undertaking when you take all the data, pick it apart, and rearrange it for better use. We also had, as in last year, the discussion of, are you a figure or are you a standard drawing? So many of the figures at the end of the chapter, and a lot of the chapters in the IDM, that are separated from the text, they're at the back of the chapter they're associated with. They're also framed up to look like standard drawings, not a figure. So it was really super confusing if you're a designer. We looked at each one of these to determine the best location. We removed the border and title block and brought a lot of the ones that needed to be in the text right next to the text that they were used for to help communicate each topic. We did want to touch on the supplements incorporated this year. So a lot of discussion has been happening internally, and many folks in the community know, for alleys, private rights of access alleys, public use alleys. We issued a supplement mid-fiscal year last year and put into place private rights of access alleys to or an alley supplement to help clarify a lot of these issues. So private rights of access alleys and the associated drawings that go with them have been updated. And we'll touch on this throughout. This will come up once or twice in today's presentation, but essentially private rights of access alleys are just that. They're intended for private homes. So the city is concerned with drainage in areas and making sure that the approach at the street right-of-way meets residential driveway requirements, and that's spelled out in these alley supplements. And commercial properties should not be accessing private rights of access alleys. If commercial property is accessing an alley, that should really be a public right-of-way. So the language within the IDM has been updated to reflect that. I will note that this conversation is ongoing as we work with the community to find and meet everybody's needs with these alleys. We're having a lot of internal conversations, and we want to make sure we get this language exactly right. So we did put this language out there for now, and we will continue to improve as time goes on. I do want to point out the on-street parking and cutback parking supplement that was incorporated. So in the past, all on-street parking, not in the past, but currently and per ordinance, all on-street parking requires city traffic engineer's approval. This happens typically throughout the platting process. When a developer would ask for on-street parking, TDO would review that request and either approve or deny it based on the situation at hand. They would use a similar diagram you see before you. Because of many issues with different plans that we were receiving, widening in front of properties, not widening properly, widening the street properly, sort of misuse of on-street parking. There seemed to be a lack of communication of what the city wanted. So working with taking this diagram that was used internally and improving upon it, and then sitting with OCE, Office of the Engineer, sitting with TDO, Traffic and Drainage Operations, our service line that is over on-street parking, sitting together for hours kind of working out the protocol and the guidelines that we wanted to put into the IDM. That supplement, again, was posted about mid-fiscal year and has now been incorporated into the IDM. Couple figures removed. So as I alluded to earlier, public use alley for commercial properties, that was removed. Also, on your right, you'll see a figure for super elevation, which when we looked at it hard enough, we weren't sure exactly what it was communicating. Some of the information was brought into the text, but most of it, our designers should know what super elevation is. Didn't seem a bit redundant to include that information. In front of you now, you will see a little bit of confusion that we were really trying to clear up. On your left is what was a standard drawing, and on your right was a figure at the back of the chapter before the review cycle. They look very similar. So we worked on standard drawings being direction to a contractor and making sure that information was appropriately there. We then also worked on what information from the figure needed to be brought into the text and tried to basically eliminate the figure, brought some cross sections into the text and kind of help with this confusion. You also see a pavement transition length. This was not part of the IDM, it was not in the IDM. A lot of questions came up with developers or capital projects on what we should transition when we're tapering down on a roadway. So this is provided, as well as minimum transition lengths are provided underneath this in this section as well. We did early on in the review cycle, the standards group did reach out to Metro. Metro has a couple items within Chapter 10 that are really coordination pieces between the city and Metro. We had some minor changes seen here. It's also worth noting that Metro is working on to develop their own design criteria. That's not out yet. I think the city and Metro are working towards, and Metro is working towards putting that out. But we did want to make sure that we touch base with Metro, went to Metro, sat down, and went through Chapter 10 to make sure that the contact information and the bus pad information that we're showing on this chapter is correct. So you see in front of you the minor changes that were made in relation to Metro coordination. One big item that we really did want to take care of and was an oddity in Chapter 10 was the cul-de-sac figure. So what you see on the left, and again, this is not meant for you to read, this is just a visualization, so don't strain your eyes or hurt yourself straining looking at this, but just kind of to show the viewer what the old cul-de-sac figure looked like. On the top right-hand corner, you'll see this circle with a bunch of lines on it. Really hard to tell kind of what that is. We spent a lot of time here and tapped into the traffic group here and some of the young grad engineers to kind of pick this apart. It really was quite confusing and from an internal standpoint. And building our relationship with the fire department here at HPC, which has been really great, working through the fire code, we've noticed that what was in our IDM was basically these figures layered on top of each other from the fire code. And in addition, the cul-de-sac diameter did not meet the fire code, was a little bit less than the fire code. So all sorts of bells and whistles going off when we looked at this figure. Spent a lot of time discussing it internally between OCE, fire department, standards group, kind of working this out. And so now you'll see a much cleaner figure showing showing not only the cul-de-sac, we also implemented or put in a knuckle for the knuckles that you see in subdivisions to give guidance on diameters and radius for this. So this applies to cul-de-sacs, and then for new type 2 PAE figure, you'll see on the right the other options that you saw in the fire code, where for PAE, you know, where the city, it's not particularly the cities or public domain, we don't have a cul-de-sac preference or a turnaround preference. That's why you're allowed these other options that you'll see here cleanly depicted and now aligned with the fire code. So with that, if there are any questions, we'll take them now. If not, I will turn it over to Ian.
Brian, we do have a couple of questions. We also are running a little ahead of time too, so we might be able to, we might leave it here for a couple of minutes to let other questions trickle in, but we can start by answering the questions that I already see.
Okay.
These are going back to chapter 6, so I don't think they got in time, but I think we can go ahead and handle it. So the first one is, will the utility design on a bridge need to be submitted to TxDOT separately?
So that's a good question. There's a difference between off-system and on-system bridges. You know, I think if it's a city-maintained bridge, then they have to be, you know, obviously submitted to the city. If it's something that TxDOT does maintain, then yes, it is best to coordinate with TxDOT as well.
Okay. Next question. Are we addressing railroad coordination in Chapter 6, or where do we address railroad coordination, if anywhere in the IDM?
So that's a good question. So Chapter 6, there is no language for railroad coordination, and I don't particularly know in the IDM if there is railroad coordination. So I think with that comment, what we can do is we have a list, and our standards group is tasked with maintaining a list of items we do want to tackle and working through that process. So I would say duly noted, and we will try to address that issue.
Great. Okay, a couple more coming in. I think this is fine because we do have a bit of a delay on it, so people might be having a little bit more time needed to get their questions in. So a couple more trickling in. I think these are questions about turnarounds in cul-de-sacs. So the first question is, what if the end of the road does not have an approved turnaround and there's no room for roadway improvements, but the utilities needed to be upgraded?
So that's a good question. So when it comes to that, the IDM, when we write the IDM, this is what the city wants and will enforce. Recognizing that there are situations where there are issues, but I think what we want to stress the importance of is we want to make sure our citizens and residents have adequate fire protection. So to that, we would stress to the designer or whoever is working on that particular project to reach out to the fire department and work with them and make sure that fire access is achievable. And if not, what can we do to make sure the fire department can get there? So it's best to reach out to them and talk through, you know, using the fire code and trying to make sure that safety is at I guess the forefront of the design is what I would say.
Yeah, great. And a couple of these are touching on the same point. If there's a conflict between the cul-de-sac design that we have in the IDM, presumably, and the fire code, which governs?
Well, I think fire would govern, right? I mean, what ultimately governs is fire safety or safety to the citizens. So if there is, you know, I think we can get into a discussion with the fire department and Houston Public Works when that issue does come up. But, you know, I think Public Works would yield to fire because I don't think anybody wants to not meet the fire code.
Right, and my understanding is that we have really tried to respect the fire code when we've come up with these standards. So we've tried to get ahead of that, right?
That's right.
Let's see if there's a couple more coming in. All right, well, this one goes, let's stay on the fire code for a second. What is the fire code requirement on a dead-end street when there's no room in the right-of-way for turnaround? So we kind of dealt with that already.
Right.
You want to touch on that quickly again?
Yeah, so same thought. Same thought is working with the fire department. The question is, not so much what can we do here. The question is really, fire department, what do you need here to provide access? So that's how I would rephrase the question. Not so much, hey, I'm stuck between two codes, I don't know what to do. I think the question more is, hey, fire department, this is our situation. What can we do to make sure it's safe?
Right. Okay, if you have the ability to answer a few more, they are coming, and I think we still have a little more time. So this is another question by Chapter 6 and the bridge question. And these are good because this is some new guidance and that I think will impact bridge projects. We want to get clarity on this. Mm-hmm. Are all City of Houston bridges being built per TxDOT specs as we move forward?
Yeah, so that's a good question. So what you'll see within capital projects or operations groups is that we lean on TxDOT specifications for bridge requirements. So whether that be standard drawings or the actual construction specs themselves, you'll see in our bid documents, TxDOT specs referenced. You'll see these other items. So I think the city recognizes, and myself having worked at TxDOT's bridge section for a number of years, for quite a while, TxDOT puts a lot of effort into the development of their standards and the construction specifications, and the city recognizes that. And so the city in no way intends to start a bridge group and create our own specifications when that effort is being done out of Austin Bridge Design section. So yes, to answer the question, we will, moving forward and in the past, we will continue to use TxDOT specs, because TxDOT's bridge specs, TxDOT's bridge standard drawings.
Okay, thank you, Brian. I think that's it. Maybe wait a couple seconds. Anybody else have any questions? We have a lot more to cover, so we can move on, but we want to try to respect our schedule too, just in case people are logging in expecting a certain chapter. So we might be a little patient with the questions.
Yeah, I think if we want to roll on, I think Luis has a lot to cram in when it gets to his part. So if you do have questions, continue to write them in, and we'll move on with Chapter 10, and we'll try to address them, leave some time at the end to kind of address them before we get to Chapter 12.
Great.
So Ian, you want to take this part away?
Absolutely, Brian. Thank you very much, and thank you everybody for being here. So moving on to our next section of Chapter 10. Well, my name is Ian Lavacek, and I'm a managing engineer in transportation and drainage operations and public works. We deal with a lot of the maintenance and operations sides of things, and we work very closely with us as the city engineer and a bunch of other departments and service lines. So I'll be talking about some of the substantial changes that we're bringing to Chapter 10 this year, and Luis will follow me up with the tail end of it. I want to talk about, Brian, we've already talked about the context sensitive, how we're trying to bring this into the IDM to be respectful of the different communities our projects are impacting. We realize that one of the great things about Houston is that we have a lot of different neighborhoods and parts of town, and they're all a little bit different. They have their own characteristics and feel. And a one-size-fits-all approach doesn't necessarily always work. And so that's what we're trying to build in, and we encourage that mindset through all of our designs, and through our standards, we're hoping to encourage that. That permeates everything. So I'll also be talking about the geometric design table that handles a lot of our actual number standards. Talk about how we're coordinating with Chapter 17, which is our chapter that focuses on bicycle, pedestrian, and transit infrastructure. One of the surprisingly bigger changes is this lane width question, and it impacts so much of what we do here. We're only talking about some relatively minor numerical changes, but it's another one of the things that permeates through a lot of our standards. So we'll see that lane width question again and again. We'll talk about street typical cross sections, some of the specific intersection improvements that we're looking for, including roundabouts, and also the change that we're talking about in terms of the design vehicle and introducing this concept of a control vehicle to the city. So starting with that roadway geometric design table, this is probably something that a lot of our consultant designers will start with. This is a burgeoning, overloaded, but very useful table of numbers that summarizes a lot of what we have in the IDM. And we're keeping it, but we're raising it in prominence in the chapter, and we're also making changes to it directly. And some of those will be, I've highlighted those on the right, the big changes. Basically, the biggest one will be these lane change requirements. And then also everything that we define in terms of the pedestrian realm, walking, biking, infrastructure like that, street trees, any of that where we try to define that here previously, we are sending you straight to Chapter 17. And what we're trying to do with this is Chapter 17 previously has been mainly our bicycle chapter that you would go to if you were trying to design a bicycle facility. What we're trying to do is make it an integral part of every single design for every street. So Chapter 10 and Chapter 17 should work in tandem, and neither of them should ever be ignored on any future project. And that's really what we're trying to emphasize. So our lane widths are changing, and they're getting a little bit more, I don't want to say complex, but this is kind of getting to that context sensitive nature where we're trying to build some of it in. Previously, our standard lane width was 11 feet with a 12-foot consideration for trucks and transit lanes, heavy usage. Now we're opening up a little bit and making it a little bit more flexible and understanding we have different parts of town, that inside 610, where we're having density that's coming at an enormous rate, we have transit infrastructure that's coming, we have a lot of stuff happening in 610 where we need more space. Outside 610, we've got a mix. We've got some of the densest parts of town outside of 610, and we also have some of the least dense. We have suburban communities that are outside of 610. And so for outside of 610, we're not even at that point defining a standard. We're giving you a minimum and a maximum, and we're asking our design engineers to tell us what makes sense. And then finally, we acknowledge that anytime there's a heavy truck route, or if there's a high capacity transit route where there will be a lot of buses running, 10 might not be comfortable. Every vehicle should fit within a 10-foot lane, but we have worked with our transit agency and trucking organizations to understand that 11 feet might be appropriate for an outside lane on those streets. So you might have a street that has a mix of different lane widths, and that's okay. So I wanted to emphasize, why are we even talking about this 10-foot standard? And the main thing we're trying to do is to maximize our use of limited right-of-way. And a lot of these areas, we have new stuff coming in, and it's great. We have new townhomes, new apartment buildings, new office buildings, and they are filling in, and they're pushing up to the right-of-way. They're adding people. They're adding people walking, biking, but also driving. We have a lot of needs that are being pushed into a limited space, and we have to make the most of it. And because in our right-of-way, we need to accommodate everything. Walking, bicycling, transit infrastructure, drive lanes, utilities, streetlights, street trees, medians, parking, the list goes on of what we're trying to fit in. So every single foot we can get back makes it so that we can provide for all of our needs. And when we don't have it, we have situations, streets where we can't fit everything. And so we'll have sidewalks that are challenging for people in wheelchairs or just walking. And this is what we're trying to avoid. And I think if we are smart about our right-of-way, we can build good streets that serve all users. The other advantage of the narrower lanes is it's one of the ways that we can subtly encourage safer vehicle speeds. It's not necessarily flat out traffic calming, but generally speaking, when people are driving in a slightly tighter space, they tend to be a little bit more careful. They tend to drive a little bit more slowly. And generally speaking, it helps us build a street that really serves multiple functions and can also be a neighborhood compatible street. And then overall, everything we're trying to do in Houston is acknowledging that we have a flooding problem in Houston, and anywhere where we can cut down an impervious surface is a plus. Anywhere where we just have a little bit less pavement and we can get everything done that we need to get done, if we apply that thinking citywide, we'll have a big impact on the amount of groundwater that we need to absorb. So then the other question here is, all right, outside of 610, we're not even defining exactly what the standard will be. We're looking for guidance from the engineers and designers who are going out to the community, who are getting very familiar with that part of the community. They are participating in community meetings to really get the pulse of the community and understand what a street needs to be. So we're looking for, and we want to take this very seriously. We don't want this to be just a quick decision, a flat application of an 11-foot lane, 12-foot lane, 10-foot lane, or whatever. We want every street to be designed in a very deliberate way. And so we have this idea of a traffic engineering study, but there's a bunch of different concepts and studies that we can use to determine that lane width. So these recommendations come out of TIAs or design concept reports. Basically, what we want to do is be deliberate about our choice and then formalize it. So we're asking the consultant and the engineer of record to recommend it. Public Works will approve it, and the decision is based on whatever it needs to be. Whether it's we have a lot of truck traffic, we have transit activity. If we have a ton of people walking and biking, we might need a little bit more space for sidewalks and bike lanes. If we're trying to control speed and the roadway capacity, anything else you want to bring to the table is fine. We want to get all the ideas we can to make all of our decisions. And that idea of a traffic engineering study, this is something we have defined in Chapter 15. So I've just showed a little bit of part of it here, but that's been in Chapter 15 for many years. And when we opened up Chapter 15 just a couple of years ago, we added to it and bulked it up. So if you haven't seen that section of Chapter 15, take a look at it, because that'll help you out with the planning and design that'll have to go into the projects that are coming out of Chapter 10 and Chapter 17. Another change and where the lane width really comes into play is some of our cross sections. And Brian's already talked about how we moved some of the cross section figures around. We have we've redrawn the figures. We brought figures into the text now to place them more directly in line with the standards. And we've cleaned up our standards too. Some of the numbers, we noticed that the math just didn't add up. So our numbers should now be mathematically coherent. We've cleaned up the tables to hopefully be a little easier to use, be a little more consistent. And where the lane width gets really interesting is that we used to define a width of pavement. And when you have a city with varying lane widths, it no longer makes sense to define a standard width of pavement. We're going to have to take this on a case-by-case, in case-by-case situation, look at each street to determine what all of our right-of-way needs are, how many lanes we need, and then what those lane widths will be to determine a width. So it's going to be a bit more of an involved process now, but I do think this will create better, safer streets as a result. I wanted to draw attention to a couple of the notes. So yeah, that down at the bottom where we have these callouts, yeah, the width not defined in the lanes, that's in our notes now. And again, yeah, for our thoroughfares and collector streets that have striped lanes, we want to look, the width will be determined by the approved lane widths, and those number of lanes need to be determined through a traffic engineering study or other approved study. So we're trying to link it all together. Divided cross sections with a median in the middle is the same kind of thinking, trying to clean it up, make it more user-friendly, and also to emphasize the need for that comprehensive view of our design. Other than that, a lot of the numbers are the same. Where we still have numbers, some of those we've taken out, we're asking for in the engineering design study. Meanwhile, this has come up a few times. I've seen a couple of projects that look to these alternative cross sections in the back of Chapter 10. It doesn't come up too often, but those are there and they're still there. Basically, how I would treat these alternative cross sections, and this is pages and pages of ideas that we have brought that we think for different right-of-ways and lane needs will work. How I would treat these is a starting point for getting the brain juices going. That we've got a lot of images, we've got a lot of right-of-ways, we're giving you an idea of what you can do on a street. But we acknowledge that a lot of designs for for almost intersections and transit facilities, bike lanes, how we're dealing with the pedestrian zone and sidewalks. A lot of that stuff, a lot has evolved since we put these alternative cross sections together. So treat these as a starting point to bring us ideas, but don't stop at them. They're just a start. I also, moving on to some of our intersection discussions from the chapter, we are trying to adopt, where it makes sense, the best intersection, because that intersections are really where we have crash problems for multimodal users, for people driving, walking, biking. We want to bring, the other part of it is we have a challenge with controlling speed. This is one of the things that through our Vision Zero process that we're going through right now that I'm hoping that everybody here has heard about and is involved with. Through Vision Zero, we're seeing that a lot of our crashes around town seem to be related to speed, which probably surprises nobody. But there's only so much we can do to encourage slower speeds on some of our major roadways. And so a concept like a roundabout is one of our few tools that can do that effectively. And so we are looking for roundabouts wherever they make sense, because they have a number of advantages when they make sense. They, on the right here, I'm showing the larger scale national results from the safety of roundabouts compared to other kinds of traffic control. And this is pretty much consistent throughout regions of the world and over time, that basically you're cutting down collisions, you cut down injuries, and you almost completely reduce fatalities, partially because you're controlling speeds, partially because drivers don't have the same degree of impact. And at the same time, what's not shown here is that for the right traffic volumes, they actually handle traffic more efficiently. So we want to see these, and we want these to be the first line of thinking for any project, that no matter what's out there right now, the first question should be, can something like a roundabout or some other idea work too? If it's a signal, can a roundabout work? The answer in a lot of cases will be no, because they do take more right of way. But ask the question, and we're open to the consideration. We had roundabouts in our previous chapter version of chapter 10. We've bulked up the section now, really just to give it more emphasis. The main important thing is just to give it emphasis, to make sure that people are thinking about this as a design option for roadways. Because any roundabout that we're designing, we're going to want to give it a lot of attention. We're going to want to make sure that we have some roundabout experts involved with them to make sure they all are working correctly. So, and some of those concepts are, roundabouts first and foremost should be designed to control speed. So a roundabout designer will look at the fastest path. Basically, all the other design elements fall out of the fastest path. So looking to control speed is the #1 issue. We also don't want the roundabouts to get too big. So we're looking for 2 entering lanes max. There's going to be some intersections that just the roundabout would have to be too big to handle the traffic demands, and it's just not going to work. But in some places where 2 lanes, or better, if a 1-lane roundabout will work, that's the best. And finally, we want to make sure we accommodate bus stops and walking bicycle infrastructure, because they have challenges. If they're done in a way that if the roundabout is designed with them in mind from the very beginning, they can work very well, but there are risks for not keeping them in the forefront of the design. And for my last part of the conversation, before I hand it over, I wanted to talk about our design vehicle section. And there's a couple changes here. Again, looking at context sensitivity, not trying to build the biggest intersections all over town. We don't need necessarily the biggest intersections all over town. At the same time, where we do need to be able to accommodate trucks, we need to accommodate trucks, so we don't have curb that gets torn up every couple of years that we have to maintain. So it's a balance. Again, what we're talking about here is, again, a starting point. And Houston's so weird, we don't have zoning. We don't necessarily control where land uses are. So sometimes you'll have streets that do have more truck traffic, for example, than you might expect. And we expect the experts who are doing the design to bring those issues to us. But generally speaking, we think these design vehicles make sense. And we've also, as I spoke before, are introducing this idea of a control vehicle. But before I get into that, I want to point out that all that text on the left that we had previously, we're basically combining all into this one table, and we've changed some of the design vehicles. And one of the vehicles that we're introducing, here we go. One of those vehicles we're introducing as a design vehicle is the DL23, which is a NACTO, a National Association of City Traffic or Transportation Officials turn template. These DL23 represent basically the biggest trucks you'll typically see on a residential street. And you see a lot of them. I mean, we're seeing more and more of Amazon deliveries, FedEx, all of these bigger trucks that are not so big, but that are using our neighborhood streets. That's more of what they look like, even compared to an SU30 shown below. We previously had this as an option to consider, and now we're asking you to take a look at it as a design vehicle. We're also phasing out the WB50, which was our standard truck, basically large truck designation template. It hasn't been supported by AASHTO for a number of years now. I think as early as the middle 80s, the truck mix on the roadways was not really matching the WB50. And so it took AASHTO quite a while to take that out. They're not ones to go and rapidly change things, to their credit. But WB50, which is in the middle there, is no longer a supported design vehicle. So what we have tried to do is acknowledge that on some streets, we do have trucks still making deliveries. They are probably not the biggest. They're probably making deliveries to the big box stores or the pharmacies, or still need to have trucks on our roadways, but they don't need to be the biggest of the big. And on the other side of the WB50, we get to the bigger of the big, like the WB62s and above, which those mainly stay on interstates. They don't usually come into the city. They're usually going to distribution warehouses, maybe activity around the port. So we think the WB40 will work for most of our major thoroughfares. And when we need it, we'll look at a WB62. But we're not looking for the WB50 anymore. And I'll point out that most of these design vehicle questions really come in special cases, and they mostly impact where I've seen them. They impact curb radii at intersections and how big the intersections need to be to handle turns of these vehicles so they don't tear up the curb. And Luis will talk about that in a minute. They also can impact things like roundabout design as well. But for a lot of the impacts of the design vehicle changes we're talking about here, we've already incorporated those into the turning radii, the corner radii that Luis is going to be talking about. And we also incorporated the control vehicle idea. And so for every street now, we have a design vehicle, and we're defining a control vehicle. And this is just a simple idea of what those two different vehicles could be. That a design vehicle is intended to be the vehicle that you're seeing making those turns on a daily basis, a number of times a day. It's the primary vehicle making that movement. A control vehicle is a vehicle that we expect to make a certain movement relatively frequently, not too frequently, and it might not be during the busiest times of the day, such that it might be totally acceptable for those vehicles to encroach a little bit. Like I can imagine on my streets in my neighborhood, they're wide, they're relatively wide, but it's no problem at all if a fire truck or a school bus or whoever kind of encroaches on the oncoming lane because there's no other vehicles out there, and can turn into the oncoming lane. A lot of this is very context specific, and to determine what movements can be controlled by the control vehicle will depend on the particular intersection. But that's the main concept there. And we look forward to seeing more of these different ideas being incorporated in designs. So that's it for my presentation. I think I haven't been watching the chat, so I will let somebody read me any questions if there are any. We'll pause here for a couple of minutes to let other questions trickle in to make sure that we're caught back up on time. So thank you.
Yes, Ian, while you've been speaking, there have been some questions that have been coming in. Okay. One question that we have is, have you considered maintenance when channeling devices such as drums and concrete traffic barriers have been placed within a 10-foot adjacent lane on the left to excavate its neighboring lane on the right for utilities, utility improvements?
It should be fine. A lot of our streets in downtown, for example, are 10-foot lanes, and we have a lot of existing 10-foot lanes around town. I believe there is a maximum legal vehicle width in Texas. I believe it's 8.5 feet, but it's plus or minus that. We do a lot of work downtown on those lanes, and we do use the channelization devices. It's a good question, but in our experience, it has not been a problem. And that we have different channelization devices available, but I don't believe it'll be a problem based on our experience.
Okay, I think to piggyback on that question, another question came in that says, you know, does the 10-foot lane create a safety issue for 18-wheelers traveling on these roads?
Another good question. This is where we're on most roads. I was looking at our traffic volumes on. I need to do this more comprehensively, but I was trying to do a selection of different major thoroughfares around town to see how much truck traffic we have. And this is a feature of our GIM system that I'm sure everyone here has used. GIMS, GIMS, it's our basically public works geographic information system. We have traffic volumes for all our major thoroughfares there. And as a couple of years ago, we started doing speed and truck counts on all of our major thoroughfares. So I was able to check that, and most of the roadways do not have significant truck traffic. Where I see them pop up a little bit is more in the industrial parts of town where you would expect trucks. And at that point, we would want to look for outside lanes that accommodate that heavy truck traffic. So it's a good question. Definitely, I wouldn't say it's probably more of a comfort question than a safety question. Because again, the truck should be able to fit within a 10-foot lane without any problem. Sometimes what happens is that the mirrors of transit vehicles and trucks might hang over a little bit, so it could be a challenge for two buses or two trucks side by side. But the idea is that if we have the outside lane kind of be the designated truck and transit lane, that should be taken care of. And then we can design all the other infrastructure, such as bike lanes that might be next to it. We'll design those with those conflicts in mind to make sure there's a suitable buffer for the rear view mirrors. Hope that helps.
Yeah, I think that does help a bit. Another question here is there a policy on how to deal with lane widths for projects with federal funding going through TxDOT's Houston district? And that question might be, you know, either if, you know, between you and Brian may be able to answer that question.
I don't think it's a policy so much, but if they are federally funded and if TxDOT is a partner in that, we do also need to incorporate their review cycle as well. And we have worked through a couple of projects to be able to reconcile our standards in ways that they might be different. So I'd say that it is part of the process for those kinds of projects. We have to respect their standards, but they do overrule in a lot of cases when those federal funds are supplied. Brian, I don't know if you had anything to add to that.
Just unmute here. Yeah, I think, you know, lane widths are what, referring to your events, your funding agreement and the documents that go along with that federally funded project. There are a lot of conversations that do go on other items. You know, if you're building a city asset, the city is going to ask that you follow city standards for most of the time, but that unravels a conversation between TxDOT and the city on that project. So would encourage, like Ian said, to have that conversation through interagency or whoever you might be working with on that particular project. But we do want to emphasize that these city assets need to follow city specs and city standards, and then make sure that to emphasize to have that conversation early on in the design process to make sure you get all stakeholders on board.
Right. We consider TxDOT to be a partner in these processes, and we're ready to work with them.
There's another question here. With these changes in design vehicles, how much consideration is given to signage posting?
signage posting, Luis, do you think, what kind of signage do you think they're referring to? Like the signage for the types of vehicles that should be using the street, or where we place the signs so they don't get knocked down? Do you have any?
There's not a lot of detail in their message. This could be temporary signing, maybe go along with the channeling devices. Maybe it's, signing requirements from the distances from the edge of the travelway. That could be another consideration. They didn't add any additional information there. So if you have any thoughts on those items, then feel free to share it with us. Sure.
Well, we don't have any necessarily specific signage for well, just this, Luis, you weren't talking about this, but if we are saying that this is a transit route or a truck route, for example, we don't have any specific signage we will use to encourage trucks to use a route. Separate from that, for the location of the signs, we still follow the same offset standards to make sure that the signs aren't. Some of this gets into our Chapter 17 discussion. I'll get into a little bit later about making sure that we have enough of a buffer between the roadway and the sidewalk to be able to put roadway signs and other needs in the right of way at a safe distance away from the edge of the roadway. So it all kind of works together, but there's not something specifically we're doing about the sign placement in consideration of the timber lane.
Okay, thanks, Ian. I think that was helpful. This concludes the question and answer portion for this topic. Any questions we did not get to will be addressed on our website after this event. And I will continue on to the next part of the topic. So hello, everyone, and thanks for joining us today. My name is Luis Garza. I'm an engineer in the Standards and Specs group at the City of Houston. I'll be giving you a summary of the updates to the IDM on intersection curb radii design. Previously, the street intersection curb radii section sent the user to IDM figure 10.06-04 at the end of Chapter 10. Now, this section has been rewritten to provide detailed guidance and ensure a balanced design approach. The figure and design data have been removed from the figures section at the end of Chapter 10 and are now incorporated into the text of this section on intersection curb radii. You may ask yourself, why the focus on intersection curb radii? Well, intersection curb return design is a critical component to intersection design. Earlier, it was discussed that the City of Houston selected design and control vehicles to design our roadways. With additional guidance in this section, the engineer will have the flexibility to ensure all users will benefit from the curb return design. You may think, that sounds good, but what are the advantages of reducing curb radii? Here are a few. They reduce crosswalk distances for pedestrians, allow for easier placement of curb ramp locations by reducing the possibility of having to make a much wider ramp to service two crosswalks, and reduce the possibility of crosswalks intersecting. They reduce traffic timing, reduce vehicle turning speeds, and increase safety for all users. So small curb radii are great, but the city still doesn't want to create maintenance issues due to curbs being broken. Engineers should make deliberate design decisions because those decisions impact the city for years to come. The following guidance is given by this chapter to select proper intersection curb radii. Standard curb radii. You may be familiar with this table. Well, its function has not changed. When there is an intersection without large curb offsets due to bike lanes, on-street parking, and shoulders, a standard curb radius from this table is to be used. The curb radii shown have been updated and selected based on swept path of the design vehicles, control vehicles, and roadway classification defined in this edition of the IDM. Some have even been reduced to align with our context design philosophy. It should be pointed out that the street classification, principal thoroughfare, and thoroughfare in the 2019 table have been combined under the term major thoroughfare, like defined under the City of Houston Major Thoroughfare and Freeway Plan, the MTFP. It should be noted that the new truck-to-truck radii should only be considered at intersections of streets that each have a daily traffic volumes exceeding 5% of ADT. Since Houston is devoid of zoning and some local streets may service heavy industrial facilities, they'd benefit from larger curb returns. Vehicle classification Bus 40 is the minimum controlled vehicle on transit bus routes. And intersection angles less than 80 degrees require engineering analysis and approval by Houston Public Works. For cases when streets at an intersection have large curb offsets due to bike lanes, on-street parking, and shoulders, a smaller radius than shown in the standard table is to be used, but must be analyzed by the engineer for safety. Let's take a closer look at the defined terms presented in this figure. Actual curb radius is the radius of curvature of the physical curb. Standard curb radius is the radius of curvature defined in the table we just discussed. The effective turning radius, which was shortly discussed by Ian earlier, is the radius of curvature created by the minimum turning path of a turning vehicle when additional curb offset is provided by a parking lane, bicycle lane, or shoulder. This intersection has additional curb offset due to a bike lane and on-street parking. Therefore, the curb return's actual curb radius can be smaller than the standard curb radius shown in our table. What guidance does the IDM give for this type of intersection configuration? This following guidance is taken directly from the IDM. Street intersection curb radii shall be designed to facilitate turning and tracking requirements of the selected design vehicle anticipated to use the facility. For example, a passenger vehicle, DL23, fire truck, WB40. Refer to the IDM on the selected design and control vehicles as presented earlier by Ian. The curb radii design should allow for frequently turning vehicles to remain in their lane. Design vehicles do not encroach into opposing traffic. Larger control vehicles that make the turn less frequently may have the option of encroaching into the adjacent lane to complete their turn. A 1-foot buffer distance between the face of curb and swept path of the vehicle should be retained for all turning vehicles. And the selected radius of curvature for curb radii is to be rounded up to the nearest 5 feet. The additional guidance and flexibility in this chapter should allow the design engineer to select the most optimal intersection curb radius for all users that also fits the roadway context and the City of Houston's overarching design philosophy. So that concludes this section of the presentation. If you have questions, please type them in the chat at this time. Please note the chapter or topic in the question.
So Luis, we got 5 minutes left, and we can use these 5 minutes to address any questions maybe in Chapter 10 pertaining to presentation that Luis just gave or any other issues. We do have one coming in, maybe better addressed for Ian. Is there a standard way of documenting the decisions made on lane widths of 10-foot versus 11-foot versus 12-foot width?
Yeah, that's a good question. I would say we are working through that formal process. Right now, we will need to get, and these projects can come to the city in a couple different ways. They can be either a developer project that goes straight to the Office of the City Engineer, or they can be a city project that comes to our capital projects team, or they can be an outside agency project that may come through our interagency team. The way we have it written is that it'll have to come to transportation and drainage operation for that approval. And I think we'll be working, we would definitely be working in partnership with our partners in our other service lines. But what I would recommend is that read through that chapter 15 on the traffic engineering study for design. And that's basically what we're looking for, to document the certain issues, to make that decision, and then you'll send it to your main contact, whether it's at Office of City Engineer or interagency, and they'll make sure it gets to the right person for their approval. And you're right, that's a good thing to get settled on before you actually even start putting pen to paper or start drawing lines in CAD. We want to make that decision early and get it approved.
Okay, good deal. So the next question coming in, kind of posed to maybe all three of us. Does the new table 10.3 curb radii? Question is, does it apply to, it applies to intersections, but does it apply to private driveways as well? You know, so I would jump in and just say, you know, the intersection design that you've seen presented today is just that intersection design does not apply to driveways at this time. But Louise or Ian, if you want to add to that, maybe.
I'll just back you up to say that driveways have their own standards. These are just meant to apply to public, basically roadway to roadway. Driveways will follow their own driveway details.
So we have a couple more minutes, maybe addressing a couple more questions. The major thoroughfare plan has two classifications for collector streets, major and minor. Are there differences in street design for either?
I think I can answer some of this. The major and minor collectors was similar to the major and minor thoroughfares in the MTFP. They're under one heading of principal collector or a heading similar to that. In our table for intersection curb radii, in the table we've also summarized those two classifications into collector streets. So that they would both apply to that. When it comes to an overall design consideration, I think that those streets, would be following our 10-foot lane, 11-foot lane requirements. Ian, if you have anything to add to that, I guess please add.
Sure, I'll just add that the minor and major collectors, I think, more apply to some of our ordinance and development language in our city ordinance. We don't have any necessarily different design guidance for the two, although again, the way ordinance is written is you can do certain things on minor collectors and not on major collectors. But both provide us some flexibility in terms of we can be context sensitive with either one of them. And if a street is designated as a major collector in an area, but as we're doing the design, we see that it actually serves as more of a neighborhood street, we can build it as a neighborhood street. Or if it's a minor collector that actually is a very critical connection, we can treat it as more of a major street. I mean, we have a little bit of flexibility there, and the standards don't box us in for doing any one thing on either one of them.
Good deal. Okay, guys, that brings us to the 10:25 mark on the agenda. So with that, kind of the recap, Chapter 10, that concludes. Appreciate Louise and Ian and this presentation today. That concludes Chapter 10. As you can see, we dove in, as mentioned, to a lot of areas here. Chapter 10 looks a lot different and is a lot bigger, a lot more improved than in past years, and should be a lot more user-friendly and try to address designer questions as we have dealt with them as they have come in.